Hello, everybody. Congratulations. You have made it to your lab final for first semester. So, today, what I'm going to be doing is talking through the lab with you since I won't be here to do it with you. Now, I'm not here. This is a completely safe lab. However, you still need to be following lab expectations. So just because the chemical risk is not high does not mean that there are no concerns for lab. We still have fire outs. You have to be handling matches appropriately. We still have a bunch of glassware out, and you are still in the chem lab. So you are still expected to be on your best behavior. Now, the lab that you are going to be doing for your lab final is a calorimetry lab. For lab finals, part of your grade is independence, which means being able to complete this lab without assistance from the teacher. All of you are going to get full points there, whether you intended to or not, because I'm not here. So, congratulations, you'll get your points, and you will definitely be independent. Now, I'm not going to leave you with nothing. I'm going to talk through the introduction with you. I'm going to draw out the setup, and then I'm going to talk through the post lab and explain what you're going to be doing in order to get your final grade. So, calorimetry lab, starting with the introduction. In chemistry, calorimetry is a technique used to measure the amount of heat released or absorbed during a chemical reaction. In this lab, we will use calorimetry to measure the amount of energy stored in different food items. You're going to do two. Food contains chemical potential energy, which our bodies convert into usable energy. When food burns, it releases this energy as heat. To measure this energy, we'll burn small pieces of food under a container of water. As the food burns, it gives off heat, which is absorbed by the water. By measuring how much the temperature of the water increases, we can calculate how much energy was transferred. This is known as heat of combustion and is usually measured in kilojoules per gram. Now, our materials. So you need two food items. The drier, the better. So two snacky food items. Think like Cheeto puffs. Things with air in them tend to do better. An evaporating dish. So this is what you're going to burn the food in. An aluminum soda can with the pop tab attached. You need a scale. You'll need graduated cylinders out. You need matches, ring clamps, and thermometers. And actually, I don't think we used digital. We used analog. So you'll need a thermometer, digital, or analog, which would be glass. I like the glass ones. Now, the procedure. I'm going to read through this. As I'm reading through this, you are going to be drawing out the procedure on the back. So you're going to be drawing it out here under the pre-lab. Model the setup, include all necessary labels. I'm doing it on blank paper, so you're not watching me flip back and forth and get dizzy. Okay. What you're going to do when you walk in there, you're going to obtain a clean, empty soda can with the pop tab still attached. You're going to measure and record the mass of the empty soda can. Now, vocabulary here. Your calorimeter is an empty soda can. So this is not a technical setup. Our soda can is going to be um, Pepsi. So I have a blue close to me. So got an empty Pepsi can. I'm going to take that can, I'm going to put it on the scale, and I'm going to say it is a set number of grams. So that's my calorimeter. I'm going to add 100 to 125 mils of tap water to the can. Now, it gives a specific temperature range. I do not need to be that picky. And actually, instead of 100 to 125, we're just going to all add a flat, even 100 milliliters of tap water to the can. And just do room temp. But the sink, you have hot and cold water. That means we're in the cold. Okay, they're not hooked up to a fridge. Cold water is just going to be tap water, room temp. So you're going to take that calorimeter. You are going to add 100 milliliters of water, which actually means I want you to have a 100 ml graduated cylinder. Those are the plastic ones, but we want to get those out. To that can. And then once those are combined, which means you're going to pour water into the can, you are going to remass that. Now, as you are doing this, you guys do have a data table, okay? So right now we would have filled out two things, mass of calorimeter, and then that's mass of water plus calorimeter. Okay. All right. Step 3, bend the top of the top tab. Bend the top tab of the can up and slide the roll through the opening. Hang it on the support stand using a ring clamp. Okay. So now we're going to get into the setup. So you're going to have a ring stand and a base. Then on that ring stand, you are going to have a iron ring. The pop cap is going to hold a glass stir rod, which you're going to put on top of the ring. And the pop can is going to be hanging from there. So the tab is going to be attached, so it's going through the tab. And then you're going to have the can with the water in it hanging here. You cannot break the pop tab. That is what is holding it there. Okay, so this is our setup. So you put the glass stir rod through the tab, and then you dangle the whole thing through that iron ring. Ugh. Place the food item into an empty evaporating dish. Okay, so you're gonna have the evaporating dish, just kind of off to the side, which is the clay bowl. And we're gonna put food in there. I'm gonna put a Cheeto because I have orange. So that's my food item. Okay. So that was step 4. Measure and record the mass of the combined evaporating dish and food. So you're going to place both of these on the scale. And then record that in your data table. Okay, I'm gonna move this paper so I can stop making you guys dizzy. On to step 6. Insert a digital thermometer into the soda can. Measure and record the initial temperature of the water. Okay, so on this ring stand at the top, you're going to have another clamp. That clamp is connected to a rubber stopper, which is holding a thermometer. The rubber stopper is giving the thermometer and the clamp something to grip onto. So our clamps can't just hold the thermometers because the thermometers are really skinny glass. So that rubber stopper has a hole in it. You will put the thermometer through the hole and then put that entire thing in the clamp. Okay, so this is going to be run down into the soda can. Now, you will need to adjust the height. In order to get an accurate reading, you want the thermometer in the water, but not at the bottom. Now, clearly you won't be able to see this, but you get the idea. You want it in the water, but not touching the bottom of the can. And then, so you need to record the initial temp of the water. Now, if you are having trouble getting your thermometer in a rubber stopper, do not force it. So you don't want to shove glass with all your might. Get a new stopper or get a different thermometer. If all else fails, look around, get some help from some other classmates, okay? But don't force anything. That would lead to broken glass in your hand. Okay, where's that at? I think that was step 6. Step 7, place the evaporating dish in the ring on the ring stand. Lower the can so it is hanging about 1 centimeter above the top of the dish. So now I'm going to place the evaporating dish with the Cheeto on the stand. So actually, we're going to cross out, place the evaporating dish. It's not going to be in the ring. It's going to go straight on the stand. So we cross that out on step 7. So I'm going to put this in here. And you want as little room as possible. You need enough room to get a match in there to light the Cheeto, but you don't want a ton of room. So just about 1 centimeter. 1 centimeter. Step 8, center the dish under the can, use a match to ignite the food. So now you're going to burn this. This might be a slightly annoying step. Some of the food items are not phenomenal at lighting. You may need to light them a few times, but you do want to ignite the Cheeto and you do need to burn it to completion. So use match to light food item, burn food to completion. You may need to use multiple matches. You probably will need to use multiple matches unless you are world's luckiest person. So allow the food to burn completely. Then That burning food released heat. That heat should have heated up the water. Record final temp of water. Now, after you've done that, you're going to take the evaporating dish out, but you need to let it cool, and it will cool fairly quickly. So just let it cool for a few minutes. Honestly, it might be cool enough to handle once you're done measuring and recording the temp of the water. And then you're going to record mass of evaporating dish plus the burnt food remnants. Do not handle anything while it is hot. But once it is touchable, so once you can grip it with your fingers, it is fine to handle. Then you're going to repeat these steps with a second food item. So not the Cheeto, you'll pick another food, and that will be your lab. Now, when you repeat this, do go ahead and get some clean water. So you will go ahead and reload this with cool tap water. But again, be very careful. You cannot break the pop cap. Pop. Do not break the pop cap. Okay. Your post lab. So all of these things are things that I have already talked through. So massive calorimeter, I said that is the weight of the empty soda can. Then mass of the calorimeter and water. So that's soda can plus the 100 mils of water. Weigh the evaporating dish with food in it. Take the temperature of the water. Then burn the food. Get a new temp of water. And then get a final mass of that evaporating dish with the burnt food in it. Now, make sure that you guys are being careful with your labels. Anytime you're doing mass, you should be doing grams because that's what our scales are in. Temperature should always be in Celsius in the chem lab. And then heat of combustion, it said it on the front and it shows it here at the bottom. That's going to be in kilojoules per gram. Okay, now of these boxes, 6 of them, 1, 2, 3, 4, 5, 6. Yes, 6 of them are lab pieces of data. Heat of combustion is something that you will need to calculate. Oopsie, pretend there's an E in there. You need to do the math. Now, I have given you a sample problem. You need to use the sample problem to figure out how to do your calculations. So you can see the equation I want you to use. This is how you calculate heat of combustion. Now, there's quite a few variables in here, but I've defined them all. And I've given you an example. I've given you sample numbers. I've showed you how to plug them in. I've showed you how to get that into a final answer. So you should be able to follow the sample and use the sample in order to perform your own calculations. Now, the only thing I will talk about specifically is the CP value. So specific heat is something we learned about, but it's been a few months. This is a constant. This is the specific heat of water. So where I plug in 0.004184, you will plug in 0.004184. So that number never changes. The rest of them will. You will not have 156.53. You will do your own calculation there. So use that sample problem, use each other to calculate your heat of combustions. When you're doing the heat of combustions, you're going to have 2 calculations. You need to show all your work because this is how you get partial credit. So you're going to have food item number 1. You need to state what that food item was. If you did a Cheeto, write Cheeto. And food number 2. Again, say what that is. If you did popcorn, write popcorn. Then down here, restate heat of combustion. Make sure you have full labels. And then answer some post-lab questions. Now, there's not very many post-lab questions. The lab should take you no longer than 1 hour. And honestly, it will take most of you 45 minutes. After that, you're going to come back here, answer the post-lab questions. These do all need to be done same day. So these need to be turned in before you walk out the door. Make sure when you turn it in, you have both you and your partner's name at the top. Oops. List your name first, full name, first and last, as it appears in Infinite Campus. That is very helpful for grading. And then put your partner's name in parentheses. The reason you need both names, we've done this before. You and your partner will be getting 1 score. Whichever sheet is graded is random luck of the draw. You need both names on there, otherwise you will not both be able to get a score. And then please also include your class period. If you have 2 partners, put 2 partners, but no groups of 4. Everybody whose name is on the sheet is getting the same score. Only one of the papers will be scored because these have to be scored quickly because they need to be posted for final grades. All right.